primary trig ratios for any angle within the quadrant. And we'll talk about what we mean by that. It really is any angle. So when you have your Cartesian plane or your quadrants, you have your y-axis and your x-axis, right? Okay. And when they talk about primary trig ratios, they talk about sine theta is equal to the opposite over the hypotenuse, cos theta is equal to the adjacent over the hypotenuse, and tan theta is equal to the opposite over the adjacent, okay? So these rules are actually really important for what we're about to do. So I've chosen an arbitrary dot here. We'll say this is some point, okay? And what we need to do is we need to figure out what angle that makes from, let's say, our x-axis, okay? We need to figure out what angle this is at. We're unsure. So the very first thing we can do, and you can kind of tell, I've already pulled this on away, I'm going to connect a point from the origin to our dot, okay? And the idea of this is we can make any kind of triangle about this. Now, not only can we do that, but we can, if I can fit this properly, hey, not bad, we can think of this almost like a circle. And your circle, we know an entire circle is going to be, yeah, there he goes, 360 degrees, right? If we go all the way around the circle, we have 360 degrees. So think of this like it's an arm that, let's see, that you're kind of pulling all the way around a circle. So there's so many different types of angles you can find here, okay? In order to find that specific angle, we're going to turn this into a triangle. And not just any triangle, but a right angle triangle. So what we've done is we've started with a point on the Cartesian plane, and then we've connected it to a right angle triangle. And that's how we're going to start to figure out this information here, or at least what the angle is. So I'm going to just turn this to an infinite cloner, so I can clone it and steal pieces later. But let's talk about how we would set this up. Let's say we're looking for this angle. This angle will be our theta. Okay, so we're in, this is called what's quadrant 1, so we'll write it in blue here. So we'll call it theta 1 to start. So sine of theta subscript 1, I'm just putting 1 there because we're going to use a couple different thetas as we go through, is going to be equal to what? Well, this triangle, we haven't really named the sides, okay? And a lot of times they're going to show you a whole new setup of something like a R, they usually call it an R, a Y, and an X. And that's exactly what this is. The reason they have the letter R there is because that's the radius of that circle. They would call this the Y because that's the up and down height of whatever the triangle is. So they'd say that's the Y value. So if you had an actual coordinate, let's just make it up, say it's 2 and 3, well, the Y value would be 3. That's how high this is from the x-axis. And they would call this part of the triangle the x part, and that makes sense because that's the coordinate of 2. That's how far that is from the origin. So that's why they call those Y and R. So instead of theta being for sine opposite, okay, because we know that theta is opposite over hypotenuse, instead what they'll call it is they'll call it Y, okay, over R. So you have your Y over R, which is your opposite over the hypotenuse. They've just used a different letter for it, right? Which then means cos theta of 1, that same angle, is adjacent. The adjacent side is side x, and the hypotenuse is the radius, okay? And then tangent theta is opposite, which is y, over the adjacent, which is x. So instead of having to figure out, and you're more than welcome to if you already know the side lengths of this triangle, instead of actually drawing the triangle in, you can use these coordinates to fill in what y and r are. Y and x, and you can even find the radius kind of using Pythagorean's theorem. If you already have this, you can already use Pythagorean's theorem to find the radius. So as you go around this, you're going to notice that there's different coordinates where things are positive and negative. So in the first quadrant, the x values are positive. I should have done that in blue. Keep everything blue in this quadrant. X values are positive and Y values are positive, okay? Which works out really nicely because positive divided by positive, everything's going to be positive. But let's say we were looking for a coordinate on this side, okay? And we're trying to find an angle. And I don't know which angle you're trying to find. It could be this inner angle. It could be the angle all the way around here. It could be the angle just from here to here. It really doesn't matter. But this is how we kind of set up our primary trig ratios. We're always trying to set up right angle triangles. So now that we've done that, let's go ahead and steal our right angle triangle. So I'm going to shrink this a little. And we'll pull our new radius out of here. Let's pull that out. So we connect it to the origin and then to our coordinate, whatever that coordinate is. So again, I'm just going to choose arbitrary coordinates. Let's say this is -5 and 2, right? We'll do this quadrant in red. In the second quadrant, all of your x values are negative values, and all of your y values are still positive values. So that plays into what's going to be positive and negative. Okay, so
sign's the only thing that's positive, I think.
Yeah, so let's take a look. I'm going to move these over to the side. Let's go ahead and build that y and r. So we know that this will be the y, this will be the x, and because this is the radius of the circle, this will be the r. Okay, so when we go to build this, sine, and we'll call this theta 2. Okay, sine theta 2 is equal to, the opposite is the y, okay, and the y is going to be a positive value, and the hypotenuse, it looks like it's over r here, okay, so it looks like we're going to have a positive value. Our radius is going to be some positive number here, AST, yeah. Our cos of theta 2 is going to be the adjacent, which is x. Now x is, like we talked about, a negative value. So x, and I might even just put a negative just in front of it, over r. So we know we're going to get a negative value when we have our cos here. And tangent of theta 2 is the opposite over the adjacent, which is y over the negative x. And anytime we have a positive and negative division, we have negative values. So that's already explaining why we're getting negative stuff there. And then we can kind of just follow the same pattern going into the other ones. Quadrant 3, right? We can have a new point. Let's say the new point's there. And we'll kind of connect our dots again. Oh, that almost worked out. Same idea. You're always going to try to build a right angle triangle here. So we'll pull this arm. There we go. So again, we're going to build a right angle triangle. So here's the little right angle. This is still the y, this is still the x, and this is still the r. So in this quadrant, our x values are negative, and our y values are negative. Oops, I kind of wrote that backwards. So erase it here. There you go. Our y values are going to be negative. So again, that's going to play into what we're doing. Our y is going to be negative. So with that being said, and do you know what the acronym is that goes around explaining this?
S. It's what's it called? It is.
That's okay. We can figure it out
is
by
it
doing this. Yeah, CAST they call it.
Okay.
C-A-S-T.
Yes.
So we'll kind of write it in here. There's a C, an A, an S, and T. Okay.
Yeah, I just know which ones they are. I keep on forgetting what the acronym is.
That's fine. So then in this one, let's kind of go through it again. Sine of, and we'll call this angle here. We're always talking usually the angle attached to the origin we're solving stuff. This will be a sine theta of the third angle, okay, is equal to y over r, okay? And again, y is negative in this quadrant, so our sine is going to be negative. We're going on the assumption that the radius is always a positive value, whatever it's reaching, okay? Cos theta of the third angle is a negative value of x over r. That's going to be negative. And then tan of theta 3 is negative y over negative x, which makes a positive value, hence why tangent's positive in this quadrant. And then the last one is our cos system here. So same idea. Let's try to build another right angle triangle. It's essentially doing the same thing over and over and over again with different coordinates. Now, I haven't written any of the coordinates in, but it's the same general idea as we go through it. Let's build our right angle triangle. We have, let's get my orange back. There we go. We have our right angle, so this part's going to be x. So anything along that horizontal x-axis is x. Anything going up and down is y, and r is the radius. So last set, we'll call that theta angle 4. So sine of theta 4 is equal to y. And in this quadrant, let's figure out what they are. Our x values are positive, and our y values are negative. Okay, so sine of theta, I need more room here. There we go. Sine of theta is y, which is negative, so negative y over r. Sine is going to be negative. Cos theta of angle 4 is x. X is positive over r. That's going to be a positive value. And then tan of theta 4 is opposite, which is y, which is negative over x, so that's going to be negative. So that kind of explains the CAST system, where cos is the only positive value in here. A stands for all. You're okay with that idea?
Yeah.
So all of these
are going to be positive.
Are going to be positive. My S is only sine will be positive in that quadrant. And then T, only tangent, because you're dividing two negatives, will be positive in that quadrant. And that's the general idea, that if you have any coordinates on the Cartesian plane, you can solve the angle that they create with the x-axis, or really any angle in the triangle. Because once you have this angle here, if you know this is a right angle, you can solve for this angle. Everything is solvable. You just have to build right angle triangles from every single quadrant that, or every coordinate they've given you in the question.